my analogy and I want to search which machine learning algorithm am I going to use. Okay, so the machine learning algorithm that you want to use is what it could be. Any idea? Any machine learning algorithm? Final year students, you can answer this question. Can I use SVM? Can I use K nearest neighbor? Can I use DT, discriminant? Any idea? I assume most of you might have covered this fundamentals. Okay, anyways, so there are two ways. The one way is to write the program. One way is to write the program, machine learning model. One way is to build up the model is to write a program. And another way is to build up the model interactively. Now see, if your data set is too small and doesn't require any pre-processing, you may go ahead and write a script for that. But if your data is too large, there are missing values, you need to clean your data, then it will take a lot of time to prepare the data set. And let me tell you this, it takes a lot of time to prepare your data set. Getting right data set or extracting right features from the data set before you go and actually train the machine learning model will consume most of your time. Okay, so if you talk about 100%, no, 60% of the time we will be only working with the data and getting your data correct. Let's move ahead. Now, for this, we are going to use Classification Learner app. What does Classification Learner help us? Classification Learner help us to create the classification models, compare the performance of the models. Now, when you say create, it provides you an option to choose which particular machine learning model you want to choose. And when you talk about compare, okay, whatever machine learning model you'll use, you can compare those models. Now, when you talk about comparing the performance of the models, what would be the performance metrics on the basis of which you would compare the models, right? So this would be, the first thing is the confusion matrix. From the confusion matrix, you can derive other metrics. What are these other metrics? Recall, fallout, precision, and accuracy. I am not showing you formula for this. I expect that you take this as an opportunity and try to find out. So I'll be explaining you the confusion matrix. Don't worry. And we'll be talking about true positive and true negative, TF and TN, or anything like that. Okay? False positive, false negative, whatever you feel like, whatever terms are there. And from that terms, you are supposed to look at the formulas for recall, fallout, precision, accuracy. Number 3, ROC and AUC curve. I'll show you ROC and AUC curve. And then one can think of, okay, I'm not getting, the result I expected for any of the model. Is it possible for me, to go and have certain trade-off? Right? Okay, fine. I think this is okay. Let's go ahead. Let's go ahead and search for, I'll search for this, Iris dataset CSV. search for this Iris dataset CSV. You may find out different websites hosting this data. Okay, you can get it from anywhere. Right? You can get it from anywhere. Let us try to go to Kaggle. And if you try to go to Kaggle, see, it will ask you to sign in, okay, or register. And you can see over here that the file format is .csv. Someone can say, okay, is it necessary to have your data set to be .csv? Can it be .txt? Can it be .xls? It could be in any format. MATLAB provides you an opportunity, to download it into any format, and then you can import it. Click on download. Download dataset as zip. So it's asking me to sign in. So I am signing using my email. And now it shows me the option. Okay, see, this is the Iris CSV file. Okay, and you can click on download. Okay, now before you download, I want to show you something, okay, about the data set. If you look at the data set, you will find out a few things. First of all, if you look at the first column, now this is a column I'm talking about, column number 1, ID, this ID. Can you see it shows you have 150 observations? So if you scroll down, you can see that the number of observations are 150. 150 observations. Fine. The first column is sepal length. And it shows you, okay, the mean value is 4.3, max is 7.9. Okay. Sepal width, petal length, petal width. They are not same, right? They are not same. So petal length and petal width, they are not same. Sepal length and sepal width. Okay. So we find out that, these values are different. Okay. So if I go to last column, which is species over here. Okay. It shows me that there are 3 values, 3 unique values. So these are my classes. Fine. So if I take the first observation, so I don't need this column actually, this column, ID column. I need these values, sepal length, sepal width, petal length, and petal width. So if I take this row and 4 features, I've been told that, okay, this is Iris setosa, right? Second observation, third observation, and so on. If you scroll down, we'll find out that the first 50 observations are for Iris setosa. Look over here. 50 is Iris setosa. 50. As we scroll down from 51 to 100, 51 to 100, can you observe over here? This is Iris vesicolor. And from 101 to 150, I have Iris virginicum. So this was about the data set. Okay, I want to download this data set, right? Because I want to build up a machine learning model over there. So see, I have downloaded this iris.csv. It's in my download folders. Iris.csv. Desktop. And what I'll try to do is I'll try to copy paste in desktop itself. Please let me know how many of you are doing hands-on with me, because this will help me in understanding I should wait for you or I should go ahead and demonstrate it to you.
Yes, sir. Participants, please reply.
Okay, thanks, Sumit. Thanks, Chintan. Thanks. Okay, so please download this. I'll show you how to upload this in your MATLAB drive. Okay. Thanks, Samir. Okay. See, I have given you the link. Download it. And once you have downloaded it, a quick yes or no will help me. Okay. I hope you have downloaded this. Now see, I'm into MATLAB Drive.
So we'll download it as a zip file, right? The entire
Yes,
zip
yes.
file.
You can download it as a zip file and you can extract it. For me, you can see, it is directly downloaded as iris.csv. Or if you want, I can share it in the WhatsApp group. Please let me know, like if someone is facing an issue, like I'll share it.
So we need to extract and then again upload all these files here on our drive,
No,
MATLAB drive.
there will be only one file, ma'am, iris.csv. Okay, what I'll do is, okay, let me use WhatsApp. I will, sorry, like this is, I should have done this earlier, but I wanted you actually to understand, okay, how to, okay. So let me go to my desktop, okay. Now I think there should not be a problem. Okay, I think now every one of you have this file is there.
Yes, sir. Thank you.
Yeah. Now, in MATLAB Drive, I have shared the folder ecgml_dl. I hope you might have copied it. If you have copied it, go to your files after copying. Under files, just see this folder ecg_ml_dl. Click on open in MATLAB online. Okay, have all of you been able to set up the directory? Like it should be MATLAB drive ECG ML underscore DL. I hope you might have been able to do this, okay? If not, and you are into MATLAB drive, don't worry. From MATLAB drive, you can navigate to, okay, from where you can navigate to ECG underscore ML underscore DL. Let us download our data set, and now it's time to upload it into the MATLAB drive so that we can use it further for our purpose, that is MATLAB Online. See, if lab offline, there have been no need for us to upload the data set, okay? Now, to upload the data set, in files, if you click on these three dots, you'll find out there are a few options, right? Okay. So in files, you can see over here, group by, show by. So if I say group by type, okay, or show by type, you can decide, okay, what exactly you want to do, right? And if you feel like you want more panel options, I'll say group by type. So see, when I do this group by type, it gives me a clear idea that my data set is under the folder additional files. And then I have MLX files over here. I'll show you again. Go to this three dot. You have an option group by, and you can click on group by type. Done. Next. Right click inside this file window and you will get an option to upload. So inside this file, you will get an option to upload. Let me know if you're able to find out this option. Click on upload files. You can go to desktop, downloads, documents, wherever you have downloaded the file. So I have it in my downloads, as well as I have saved it in my desktop. So in desktop, I have this iris. Click on open. There will be a dialog box and click on OK. Done. If you are okay with this, let's go ahead. Let's go ahead. Shall we? Shall we go ahead? Yeah, thank you, ma'am. The first thing that we are supposed to do is to import the data. Now, please, I'll request you to please pay attention first. Like I will repeat this later on also. The first thing is to upload the data. So there are options. The options are, you can click on this option, go to Home tab, and under this variable section, there is a button over here to import the data file. If you click on this, a window will get open. And if you have set your directory correctly, MATLAB drive ECG ML underscore DL, where you have uploaded this particular file, you can click on this file and you can say open. Else you can see these are the different formats that are being supported over here. Okay. By default, it's recognized data files. Click on open. Done. So I'm done with this. Now see, I am pressing my control key. I do not need this ID column. I need sepal length, sepal width, petal length, and petal width. So you can observe that whatever data you want to import should be under this blue color shade. If you click on by mistake, lazy, if you click on only one cell, single cell, so the shaded part is only one cell. And after I click on import data, it is going to import only a single cell. This is not correct. So what you can do, if it happens like this, you can go for Control A, you can select the enter data. Do not select the column which you are not interested in. And simply select import data. And the data is imported. Right? Okay. Now please try and do this. So let me type clear and CLC. We will do this. So you can click on import data. Click on iris.csv. Open. Import data. Iris. Open. Okay, are you all doing this? Please let me know. If there is any issue, you are unable to do it, let me know. This is an important part for us. See, I have my data right over here. As I told you, press the control key. Click on column A, it will get deselected. And now we'll be importing only the column B, C, D, and E. Next, click on import data. And you can close this window. Anything you want to ask? Anything? Have we completed our step 1? Next, go to plots. You may see that everything is disabled, right? Can you observe? Everything is disabled. So we'll do one thing. Let me click on iris, double click on this iris. And I hope you are able to see now. If you see this, it's telling me the mean, max, median, missing, class. So for sepal length, I'm already getting mean and max values, right? For sepal width, I'm getting it. For petal length, for petal width, species. And if you observe the data type for species, it's categorical. Can you see? This categorical. I hope this is okay with you, right? Now, I want a plot of sepal length with respect to species. So see, I have selected 2 columns. I have selected sepal length and I have selected species. If I go to plots and I click on box plot, can you observe it has already given me the box plot? Please let me know if you're unable to do this. I'll show you this again because this is the interesting part. Close everything, close iris also. Put CLC, clear everything. Go to your workspace window, double click on iris. Try to read out, okay, what is there in column 1, column 2, column 3, column 4. Now, sepal length may not be same for all the 3 species, right? So if I take sepal length, if I want a box plot of sepal length and species, I want a box plot of sepal length and species. And if I go to plots and I select box plot, see, it has generated result for me. I'll explain you this result. And for that, let me try to use the tools. Or we can go to format, you can use insert, whatever you want. Okay. If I try to show you this, let me take some arrow line or arrows. I do not have a, okay, let me see if I can take this to paint. No, okay, fine. See what I want to focus on. If you look at this red color lines, if I click over here, can you observe that the median values are different for all? Can you observe this? For example, for Iris virginica, it's 6.5. Okay, for Setosa, it is 5. I'll do one thing. I'll delete all data tips. I want to show you something. If you look at this Iris Setosa, the median value is around 5. If I go to Iris vesicular, the median value is 7. And if you go to Iris virginica, the median value is 6.5. Also, if you look at the max value and the mean value, so if I look at this value, this is 4.3 and the max is 5.8. Minimum is 4.9, max is 7. Minimum is 4.9, max is 7.9. So what we see over here, that the sepal length of Iris Setosa is not similar to the values of Iris vesicular and virginica. But the Iris vesicular and Iris virginica, okay, their median values you could check 6.5 and all that. And we also see that it would be difficult for me to actually classify or separate out the two classes, vesicular and virginica. So Setosa is easily separable, but vesicular and virginica are not separable because you can have a box plot and you can check it. Fine. Now this was the box plot for sepal length with respect to species. Let me go to Iris again. I do not want sepal length now. I want sepal width with respect to species. Again, you can go and have a box plot. So one more figure will get added over here, okay, which is sepal width and species, right? Likewise, we can go and keep on adding, okay, whatever box plots we want. Let's try to take petal length and species, and let's try to choose box plot. See, there are other plots also. You can go and you can decide, okay, what plots you want, and you can simply go ahead. Okay, let me close this. Okay, has anyone tried? Okay, let me close this. I want to show you the scatter plot, but I'll show you it other way. Okay, have you tried this? Has anyone tried this? Now, if you observe at the background, I am already able to create the box plots like this. So if I copy this command, I don't want to use X label, Y label. Okay, I will use it later on. And instead of iris.sepal length cm, if I write this petal length cm, comma iris species, enter, it's going to give us me the same result. Now this result is for petal length, but since we have not added any X label, Y label and title, we won't be able to find it out, right? But if I try to repeat this command for, let me Control V. What I observe that even by plotting the command or by executing the command in the command window, I am able to get the same result. Okay, fine. Let me show you, let me type CLC and let me go for one cluster, scatter plot. So what I've done, I have selected sepal length, I have selected petal length, and I have selected species. And now I want a scatter plot. So see, depending upon the variables that we have selected, we have got the options. The options are either you can go for scatter and histogram, which is a combination of scatter with histogram. You can go with box plot. You can go with G-scatter. I'll go with G-scatter. Okay. Can someone look at this and tell me, okay, what exactly is happening? I told you that one class is easily separable. So if you look at iris sedosa, the blue color dots, they are easily separable. What about the red color dots? And what about the yellow dots? Are they easily separable? Are they easily separable? We'll find out that if I use the parameters sepal length and petal length, I may face there are some problems. Let me take petal length, petal width, and species. Scatter. Take a new figure. Okay. Go to iris and let me take sepal length, sepal width, and species. And you take a G scatter. What you'll find out, you'll find out that there are some problems, right? If you see, if I take sepal length and sepal width, it's not the best way to visualize the data. The best way to visualize the data is like if I go to figure 1 and if I take petal length and petal width, I could see that it's easy for me to what? Separate the data. Okay. So here at this boundary between red and yellow dots, I can put one partition. Now near the partition, there may be some misclassification, but it's okay. But I should be able to at least understand that sepal length and sepal width are the most correct parameters that I should use over here. This is what we are able to understand in exploratory data analysis. So dear students and researchers, I want to make this very clear that we should not directly jump ahead and we should start with the machine learning problem. As I told you, the most of the time is been taken up by data preparation and exploratory data analysis. Let me close all the figures. The most important thing you might have observed in all the columns is I have 0 missing values. So this is a good data for me to start. Let's close this window. Okay, go to home. Let me put the layout to default and let me type CLC. Done. I'm done with this exploratory data analysis part. Let us move ahead. Now it's time for us to start with the apps. So from the home tab, we imported the data. In the plots tab, we have performed the exploratory data analysis. Now it's time for us to build up the machine learning model. So go to apps. Search for regression learner app. As I told you, let us suppose I do not have a favorite tab. Where would I find out where my app is? So if you scroll down, and you move to the section machine learning and deep learning, you'll find out over here there are options: classification learner app, regression learner app, and so on. We are going to start with classification learner app. So let's click on classification learner app. And let me know if you're able to launch this window. Fine. If you are able to launch the app, you might have observed that there are 3 tabs over here: learn, test, explain. You go to learn tab. In the learn tab, click on new, and now you have an option over here to upload your data either from workspace or from file. See, it may happen that you are working as a team, and in a team you have divided your task. So there are people who would be acquiring the data and cleaning the data and will make this data available to you in the form of an Excel sheet where there are no missing values. You have already performed extracted data analysis. So you can say, okay, so instead of directly loading it into MATLAB Workspace, can I directly load it as a file itself? Yes, there is one option to do this. You can go to file, but here I have already loaded it into my MATLAB Workspace. So I'll click on new session from Workspace. Under dataset variable, you will choose your dataset name. My dataset name is Iris. We have discussed this even yesterday that when you want to perform classification tasks, the output column or your classes should be categorical. So you might observe over here that I have 5 columns over here. Okay. If I choose choose any one of the other feature other than species, like sepal length, you might notice a warning sign at the bottom. And it shows you the data type double. I want the data type to be categorical. Next, you already observed you have sepal length, sepal width, petal length, petal width, and species, right? It automatically gets unchecked. You have an option for cross-validation, hold-out validation, and resubstitution validation. Now see, what is this validation scheme? Most of the time, you may notice that we do not have a larger data set. And when we do not have a larger data set, there are chances that our model may start giving you overfitting. So what is overfitting? Overfitting is like, we have trained data and test data. So for the training data, we are getting 100% accuracy. But when we have a test data, the model is not actually able to classify. So it's like you go to a classroom in a unit test, you are or at home you are able to answer all the questions, but when we go to examination, we find difficulty in answering that question. So what we can do is we can use this scheme cross validation, okay, sorry, cross validation or hold out validation. So cross validation is a scheme which will help protect against overfitting, right? And it provides you by folds. So it is like if you keep 5, the data is folded 5 times, 10 times, 20 times, and so on. I am keeping this to be 5. You want, you can change this to be 10. Okay. Default is 5. What is next? We are talking about machine learning model, but we have not split up the data, right? Now to split up the data, what should be the percentage? Yesterday we have seen the example where the splitting was 60-40 for train and validation or test. Then we in the deep learning on-ramp certification course, we saw that it was 80-20. Here, if we try to click on this checkbox, percentage is 90-10. So what is the correct percentage? There is no to answer this, there is no de facto standard for this. But to tell you that there should be a sufficient data so that model may learn features from that. And therefore, most of the time you'll find out people try to keep this as 80-20. Most of them. As I told you, there is no such thing. Like you can try this your own end also. If I take 60-40 and if there are no features to learn, the model may give you misclassification. So before I take a bio break of 5 minutes, okay, you can just go ahead and perform the tasks. After we come later on, when we come to this particular app again, we are going to train the models and compare the models and look at the performance metrics, right? Okay. Okay, dear participants, I'd just like to understand, are there any challenges? Moving ahead, let's click on Start Selection. And I had already shown you the accelerated data plot. So this is a scatter plot. On the right hand side, I have predictors. So I can take the predictors to be petal length. And over here, I will take it to petal width. And I am getting the same representation as you can see, as I've got earlier. Now it's time for us to select the models. You can go over here and you can choose, the different classifiers or machine learning classifiers that are available to you. Reading out the categories, decision trees, discriminant analysis, logic regression, support vector mechanism, and so on. So what I'll do is, I'll take a tree. Okay, it gets added. Next, I want to add, let us suppose, SVM. I'm taking linear SVM or quadratic SVM. I'll take a quadratic or cubic SVM. You can decide. I'll take quadratic SVM. I'll take, let us suppose, KNN, right? So you can take fine KNN, sufficient enough. Click on train all, and you'll find out that the training process will start. It can show parallel pool has been started, and you can see that under models section, the training has started. And slowly you are also able to see the results. Let me show you, there are two models which are giving us the same accuracy. So before we actually compare the models, you have an option over here, sort by. So you can say sort by accuracy. So there are two models. The model number 1 and model number 2 are same. So you have tree and you have KNN, fine KNN, which is giving you what? Okay, an accuracy of 95.8%. Now, since both of them are giving the same, let's try and see, if there is an option for us to choose. So we had chosen SVM. Yes, we have chosen SVM. We can take boost trees or something like that. Okay, I'll take boost tree also. Okay. And now what I can do is click on the model and click on train selected. So that's how we can choose the model and we can train. And then you can see, oh, this model is giving me a very, very bad accuracy. I don't want this model. You can right click and click on delete. Now to tell you this, you should have some experience of how this model works. If you cannot simply go and click all the models or any models and start doing this. Anyways, click on model 2, tree. It gives you, what is an accuracy, total cost, model hyperparameters, additional training results over here. That is precision, recall, F1 score, and so on. Let's look at the confusion matrix. Now this is the confusion matrix. And if you put it like this, true positive rate and false negative rate, I may be able to say the confusion matrix. Now, before I actually show you the confusion matrix, let's go to model 4. These are the training results for model 4. Click on the confusion matrix. Okay, now since I have to compare both of them, let me go to layout and let me put the compare model. Both the models, model number 2 and model number 4, okay, are compared over here. Right? Now, how to make this confusion matrix more simpler, how to understand this particular number. So while training, we splitted up the data as 80-20. Each class has 50 observations. So 80% of 50 becomes 40. So I have 40 for training Iris setosa. This is a blue color cell. Adjacent to this cell, I see there are no numbers, they are blank. So 40 observations are correctly classified as 40. Next, here in this blue cell, it has to be 40. But I see a number over here, 37. So for iris vesicolor, 37 has been correctly classified and 3 has been misclassified as iris virginica. What about iris virginica? 38 has been correctly classified, 2 has been misclassified. Now this was with respect to what? The confusion matrix. So if you want to select the model, how are you going to select the model? Look over here, the metrics. What are the metrics? Prediction speed, error rate, what you can say, or total cost, training time. And you can also see one more important thing, that is model size. So tree model size is 5 KB, which is small over here. But if you compare to the training type of both the models, okay, the first model, that is tree model, has taken 6.52 seconds. KNN has taken 3.46. Are they the only parameter? And is this the right time to choose the best model? No. Let's go to test tab and click on test all. When I click on test all, oh, the results are not same, right? So for training, tree was giving us an accuracy of 95. KNN was giving an accuracy of 95. When we test them, tree gives me an accuracy of 86.7 and KNN gives me an accuracy of 90. So let's try to look at confusion matrix for tree and confusion matrix for test. Look at the diagonal elements, diagonal cells. So 20% of 50 is 10. So in this blue color cell, there has to be a number which is close to 10, which indicate there were misclassification. The number of misclassifications, okay, are less. So if I compare both the matrices or confusion matrix, I see that I'm getting a better results for KNN. If you want to plot ROC curve, you can go and you can plot ROC curve. So this is the ROC curve. Okay. You can select like you want the ROC curve is 1 actually. That's the reason you're getting it like this. I'll maximize this window and I'll show you this later on. Okay. And for tree, if you want, you can plot the ROC curve. If you want to plot, you can also plot precision recall curve. Depends upon you. Like this is precision recall curve. like what I've plotted over here. And you can keep on adding. What I'll do is I want to concentrate on what? On model 4, which is KNN. What about SVM? Here's a test is 96.7. Okay, so with respect to model number. Okay. Fine. I have over here a result table. And in the result table, I can compare all the models. So see how to compare. You go to this column, accuracy validation, and you can sort it with respect to descending and ascending values. So what I went accuracy validation to be arranged in descending order. What about total cost validation? Okay, it should be ascending. What about accuracy test? So if I say that should be arranged into the max accuracy test is 96.7, so it's max for SVM. But what about other parameters? I don't know if I could show you this parameter. Can you see the total cost? Now it depends upon you. There may be more parameters for us to compare. I feel if you feel like, you are happy. So this is confusion test for SVM. Okay. And this is confusion train. And if you feel like you want to choose SVM, click on SVM. If you go to summary, observe that its model size is 17 KB. Observe its training time is 12.388 seconds. And that's the reason you'll find out it's not highlighted in the test tab. If you go to test tab, it's not highlighted over here. Okay, fine. So you need to check all the parameters. Okay, you can also check the total cost validation is 7 over here. You can check all the parameters. Anyway, like if you feel like SVM is the best model for you and you're not concerned with the model size right now, you can click on export model, click on export. The model will be saved. Okay. If you want to generate the function, click on generate the function. So there will be a new script now, okay, which will be at the back end. So you might be able to see that I've been able to generate the function over here. So this is my function. And this function has been generated by the classification learner app. You can see over here. Next, you can see now it's telling me that if you have exported the model, now with the help of model, you can do some prediction. So what I can say, if I type this command who, I have my data and I have my train model, right? And I can use this instruction. So if I take this T predict is equal to iris iris. I take the first row, okay, comma, and I want it to be starting with the first column to the n-1 column. Look over here. This is my new table. I don't know what is the class of the flower, right? So what I can do is Let me copy this. Right? And I will put over here T predict. So it has given me scores. Okay, can you see 0 score? So it is saying that it has been able to correctly identify that the class is Iris Setosa. Or you can simply use this. It gives you, it is what Iris Setosa. So I think this is actually indicating us that how classification learner app can be very useful for us. Let me close this. Clear my environment. And now I want to make use of this classification learner app with the ECG signal. Go to home, reset the layout. And now I have few live scripts with me. Live script 1, live script 2, 3, and 4. See, here, before lunch, I am going to talk about ML feature stats.ml. After that, we will be talking about script number 3, ML features domain knowledge. And then we will talk about deep learning and CNN as we have discussed earlier. Let's click on this. First, I will explain you the code, and then we will see the demo. In this particular code, or in this task, we have to classify the human electrocardiogram ECG signal using different machine learning algorithm. So we are going to follow some steps. What are the steps? We will go through the workflow of simple feature extraction, and then we will train various machine learning models that can identify the 2 heartbeats, normal, sinus rhythm, and arrhythmia. So if you go to a cardiologist will ask you to go for an ECG test. Under ECG test, if everything seems to be normal, it will be written over there, observed normal sinus rhythm. But if there are some issues, then it will tell you, okay, this is an issue. But the generalized term, very, very basic term is arrhythmia that we are taking over here. Now for this, we are using the data set from a challenge, which is PhysioNet 2017 challenge. We have a hyperlink over here. Let's go to this particular website and try to identify what it talks about. So it tells you, can you see this introduction? The challenge aims to encourage the development of algorithm to classify from a single ECG-led recording. The recordings are of 30 to 60 seconds, and it shows normal sinus rhythm, arterial fibrillation, AF, alternative rhythm, or it's too noisy. It's to be classified, right? But they have told you, okay, that this is how, these are the different conditions, where it could be classified. You are supposed to go through this documentation, and the best thing you'll find out is the quick start. They have already given you the data set into training, sample, okay? They have given you .m files also, which talk about challenge.m, which is all about the challenge that they are talking about. They mention the rules and everything, right? Someone may say, okay, this seems to be bit, what you can say, bit older data set. Don't worry. I'll just try to focus on this waveform which are present over here, because this is what we might be interested in. You see over here, there are different recordings. So recording A is at the end 1, 0, 0, 0, 0, 1. It's a normal rhythm. All the section P, Q, R, S, and T are present. If you look at the recording A00004, we'll observe that someone can tell me what is happening. You might find out, okay, the P part seems to be missing, right? There may be other rhythm also. Noisy recording, the electrode doesn't capture anything. But anyway, what you find out, it's a plot of amplitude with respect to time seconds. Or this could be different samples. So if any of the peak is missing, we will indicate that this is a problem, okay? Or it's a heart condition. I'll request you can go through it. All the things are given for download. You can click on this and you can download. Someone can say, what about if we want to go for a new data set? Don't worry, you click on physionet.org. You click on challenges and you will find out all the new challenges are present over here. A tsunami of false alarm or product. So a future of AI in healthcare, all of you can go here, you can see code, you can see demos, related papers and all other sort of things, okay? And you can also see, you know, if you're looking for community challenges, see these are the different challenges. So if you're in final year, why don't we take a data set from here? Right? Someone thought of, okay, I want to take this data set. What it could be, what I just saw. Okay, pulse oximetry correction models. You can go over here, read everything, okay, download the data and start using it. Anyways, we've taken the data set from here. Where is the data set? If you go to this additional folder, the data set has already been added for you. So if you go to helper function, you'll find out there is a data set which is physionet data.met. Already the data set has been given to you. And there are some helper function because we are talking about a case study right now. Let's clear the environment and add all the files that we'll be requiring. Look at the index, the table of contents. I have already made you aware how this is over here and how the hyperlink exists. Load the data. When you load the data, physionet.mat, I'll show you, like once you load it, you will have labels and signals. So if I type this who command, okay, you can find out I have already labels and signals. So the number of signals that I have are 5788 signals and labels are 5788, and label can be seen as categorical. So if I click on this labels, you can find out that there are N, A, right? Okay. And if I click on samples, you'll find out, can you see this is 1 by 9,000, 1 by 18,000. So as you might have seen, it talks about the recordings in seconds, 30 seconds, 60 seconds. So there may be instances where there are recording more than 30 seconds or 60 seconds. Oh. Right? Okay. Once we have loaded the data, let's go ahead. Let's look at so I've shown you signals, the duration of the signals. Okay, I have shown you the labels, the first 5 labels, and this is the summary. Okay, can someone answer whether this data is a balanced data or unbalanced data? This is an unbalanced data, right? Okay, fine. Let's try to plot all the signals. Now, if you try to plot all the signals, you may find out that most of the signals have length around 9,000. But there are other signals also where the lengths are between 0 to 9,000 and 9,000 to 18,000. So now we have to decide, are we going to keep those signals which are lesser than 9,000 samples? Because it may not be possible for us to retrieve the information that we're looking at. So we can take a decision. Let's discard those samples which are between 0 to 9,000. What about the samples between 9,000 to 18,000? They do contain some features which may be useful. So can we split those 18,000 into 2 parts? 9,000, 9,000. Okay, we will see this. Before that, let's visualize the signal. If you visualize the signal, you will notice, and what you notice, look at normal rhythm and RTF fibrillation. I clearly see that this P peak is missing. Okay, now we have understood that what a challenge is. Let's go ahead and prepare the data. So as I was discussing, the ECG signals may be of different length, right? So we can decide to pad or truncate them, but we want the samples to be 9,000 samples long to maintain the uniformity. So we have built up a function. The function is at the end of the script. The function segment signal ignores the signal with fewer than 9,000 samples, as we decided or discussed earlier. If the signal is over 9,000 samples, we'll break up this into 9,000 and he will ignore the remaining part. So the question could be, if a signal is of duration 18,500 and you split it, you will get 2 signals of 9,000, 9,000. And the remaining 5,000 will be lost. Now, once we do this, we should be able to see the total number of signals that we have. Okay, this bar plot is suggesting that now we have all the signals which are of uniform length. Done. Let's come to the most interesting part, feature extraction. We have already discussed that a machine learning model uses features or predictors. And these features are related to the output variable. Now, extracting the best features require the domain knowledge. If you do not have the domain knowledge, the best way is to start with the statistical measures of the data. Okay. And what are the best features? The best features are those that display large difference between the two classes. For example, if I go for a moving average value, okay, and the moving average value for one class is far away than the other class, this is a good parameter for us to classify them. But if their values are close enough, that parameter may not be useful for us. Moving ahead. Let us try to use the statistical features like median, standard deviation, skewness, and kurtosis. And let's try to plot the histogram. Don't worry, all these files are already being shared to you. Okay, histograms. So there are two classes, normal sinus rhythm and artificial fibrillation. And if we try to plot the histograms, you can observe that this is mean, median, standard deviation, kurtosis for normal signal. Okay, and mean, median, standard deviation, skewness, and kurtosis for abnormal signal. And what I could see is like mean, median, standard deviation values are the one which are deviating from each other, and therefore we can say, okay, this might be few good parameters that actually we could use. If you go to your data, see, you get a script over here, extract HCG features.mlx. And inside this, you have been already given from where it downloads the data. Okay. And you can see it's using Wavelet. So this is the one, that you would be using in the later part. But if you feel like I'm interested in this extract features, what exactly it has, right click on this and click on open. This function is already shared with you. If you go to this function, you will find out it's given over here how it calculates the median value. So see, create a variable name feature table and store all the features in this. So you have mean value, median value, standard deviation, mean absolute deviation, interquartile, range, percentile, skewness, sample, and everything. And at the end, you put a table over there. So if you try to put a table over there, see, for every signal now you have represented. So for every raw signal now you have calculated the features. The features are mean value, median value, standard deviation, mean absolute deviation, and so on. Now you can prepare the data for training and testing. And we have decided that there is no certain ratio to split up the data, right? So one way to split is like you can think of keeping 80% for training and remaining for testing. So you have length, right? So this is a function, CV partition function. Don't worry, here we are simply splitting this into training and testing data set. Now it's time for us to load the classification learner app, right? Okay, so let's execute this section. Now I have already covered this part, so this might be somewhat similar to what we have done earlier, and you will face less challenges. So many variables are there. So select train data. You can select class which has 2 unique value. If you go to your tutorial, see, it tells you, it has already been highlighted what you're supposed to do. You observe that there is no splitting over here, right? We don't want to do splitting because we have already got the test data. Okay. new session from workspace. Select the train data. Class is selected. Categorical. It has two unique value A and N. Fine. Let's click on start session. Right. Now, what are the models that are being chosen over here? Right. So see, it has been taken all quick to train. We'll do the same. Close everything. Let us click on all quick to train and click on train. So the training has started, and we could see till now KNN has given you the best accuracy of 87.9%, right? So let's close everything. This is the model. Okay, you can look at the confusion matrix for training. Fine. Let's go to test. Select test data from the workspace. Select the test data. Click on import. Test data imported. Click on test on. Yes, so model 2.9 is the best model. Click on the result table. And as discussed earlier, you can put this validation accuracy in descending order, okay? And accuracy test to be also in descending order, okay? So the model, and as I told you, see, there are few things also, the total cost. You can decide, okay, how you want to put it. Other parameters also over here. Total cost validation and all other sort of things. And you can choose. But result table is one thing. As I've told you, you are also supposed to look at the parameters. Done? Okay. What is next? So we have been able to launch the classification learner app. Okay. We have trained all the models. Right. We have chosen the test data. We have seen KNS gives us the best result, right? What is next? So before we take a lunch, observe that we have been able to reach the accuracy up to 90%. So accuracy that we are getting is 88.2% if you notice this. But the data set is highly imbalanced. So what we can do is, someone who has a knowledge of working with biomedical signals or heart signals may try to use some better features. Now, what are these better features? So the better features are, you can extract more powerful features. So there is a script over here, _ML feature domain. It will help us to, get a better model. Next, addressing data imbalance. This is also really important. You may find out that in our case, the data set is almost 10x. So the chances of misclassification are more. So 10x more instances, of normal ECG compared to the people, who have a heart condition. Normal ECG compared to a heart condition. So we need to take
care of that, right? Okay, so we should have as much data as we could. Last, hyperparameter tuning. This is also important. Now, you have already covered the first two part. You've addressed the challenges, the first two challenges. And then you feel like, okay, we are not able to get the performance as desired. What we are supposed to do? Okay, so can we go and can we set the right parameters of the model to achieve optimal performance, like training time, time taken for training, time taken for prediction, the size of the model, okay, and so on. So this may add a small accuracy to you, okay, but then hyperparameter tuning is a really important part. We do not want a model which is slow at prediction, right? Even we do not want a model which is very fast prediction. It may give you wrong prediction. We want to choose a model which is an optimal model, which gives us an optimal performance. Okay. So this is where I will like myself to stop. Okay, but you can see like all the functions which are required are being shared over here. I have already shared this file with you. So I think this is a good time for us to break, and let's meet again in the second part.